Assalamualaikum warahmatullahi wabarakatuh to Madam Fatia and to everyone that's watching this presentation. My name is Yang Maizra Safira binti Manshamuddin, and today I'll be presenting the assigned technical paper review. So my title of the assigned paper technical review is Stratigraphic Modeling of the Western Taiwan Foreland Basin, Sediment Flux from a Growing Mountain Range and Tectonic Implication. This is the overview of my presentation. It's divided into 6 parts. That is introduction, background studies, objective, methodology, and there's another part that is a discussion and results, conclusion and recommendation and reference. For introduction, so a brief introduction about this paper review is that it's about the Western Foreland Basin in Taiwan. Is a very particularly a suitable place to study the interaction between tectonic and sediment flux. This is because it's very young and still active till now. Second, the Western Foreland of Taiwan is a historical basin with a relative deep water sedimentation. As for now, observably in the modern setting is in the south of the origin to a late balanced field stage, where the shallow marine environment persists until today, despite the numerous amount of sediment supply to the ocean by rising the Taiwan Mountains. In a sense, Taiwan origin is characterized as mainly an ancient foreland basin system, same as the Molas Basin of the Alps. So for objective, there is 3 main objectives of this paper review. That is to test the information of different tectomorphic scenario in controlling the stratigraphic architecture of the Western Foreland Basin of Taiwan. Second is to discuss the implication for understanding the foreland basin architecture within the well-constrained source to sink setting. And lastly is using 3D stratigraphic simulation to compare and match between the simulation and the observation of the Taiwan Strait or the Taiwan Basin. For the background study of this paper, first of all, I will start by introducing the Taiwan Foreland Basin area. The Taiwan Mountain is rising almost 4 kilometers above sea level, and it was formed by a collision between the Philippine Sea plate and the Eurasian continental shelf. So the arc volcano is associated with a subduction below the Philippine Sea plate ceased between roughly around 6 million to 3 to 4 million years ago, when the arc resisted subduction and collided with the Asian Pacific margin to form an initial accessory wedge. So this both diagram from the right is the schematic stratigraphy of the foreland basin of the Taiwan of the Taiwan Basin from the north to the south. Note that the change in the Lister's logi in central of the South Taiwan is due to the topographic barrier called the Paikan High, which separated the northern Taishi Basin and the southern Tainan Basin. We also going to get back to this part where we're going to see how Paikan High affected the separation between the both basin of Taishi and Tainan. So uh, the next part of the background study is the depth map. Here, this depth map show more clearer of the Paikan Basin, uh, separating the two basin of Taishi Basin and the Tainan Basin. So in this Taiwan foreland have approximately four individual basin. That is Taishi Basin, Nanjitao Basin, Penghu Basin, and the Tainan Basin. So the Nanjitao Basin is partially covered by a distal foreland basin sequence, and the Taishi and Tainan is separated by the Pakan Hai, as I said before. So here is a schematic cross-section of the Taiwan origin. As you can see from this diagram, it's actually a form of passive margin where one passive margin where the orientation plate move more to the southeast. Okay, next, below in the C image is the seismic interpretation drawing. This seismic interpretation drawing is modified by UN Chow according to the paper review. So, the foreland basin sequence on lap onto passive margin deposits will increase the depositional hiatus towards the fault plunge. Deposition hiatus meaning it's a foreland conformity where conformity. So next is the Pliocene quaternary sediments directly overlay the lower Miocene strata. Next, the methodology. The methodology used for this paper review um, to conduct this simulation, this test simulation. So this is the workflow of the simulation. So as explained, the purpose of this simulation is to test the influence of different tectomorphic scenarios in controlling the stratigraphic architecture of the Western Foreline Basin of Taiwan with a focus of constraining the magnitude by the sediment bypass out of the basin and its implication for understanding the overfill and underfill evolution of the foreland basin. So for the two box first on top, subsidence uplift and sediment flux is the main two input that needed to use uh, uh, as for this simulation. The method starts off by introducing the basic physical law of the 3D stratigraphic model diagnosis is an equation by introducing the equation. Then they review the foreline basin subsidence and they review the sediment flux pattern, then set up a numerical experiment. So in first step is they introduce the law of a law of physics of the 3D stratigraphic model Dionysus. So this is the equation. Next, after they introduce the equation, they review the foreline basin subsidence. So the foreland basin subdivision here, the first map is the compact, shows it's a depth map. It's a depth map that shows the decompacted sediment thickness in between uh, four phases, in different years. Then for the right side diagram for A and B indicates the tectonic subsidence history from the stratigraphic section, and each have a colored line that correspond the section or the corresponding of each section in the fault and thrust belt of the Taiwan Foreland Basin. Next, this is the sediment plug pattern. So this image, they reviewed the sediment flux pattern image. You can see here, this is a smoothed image of the substance map of each simulated intervals with a tectonic subsidence used in the program and the total subsidence effect of the sediment and the water loading. The sediment, the center in the north and the south are separated by the Pican High. This shows how the Pican High separated the two basins. There's Taishi Basin and the Tainan Basin. I can see near here, they really shows how they separated through time. Next, result and discussion. So result and discussion. First, this is the result for the simulated sediment flux result. So for the first image, A is the sea level history, B is the modern bathymetry. C is the constructed in 3D image of the facies analysis in the western foothill. The second picture related to the first picture as well, because the right picture here shows the thickness of each blocks from the 3D data result. Next, both of these are the cross-section results produced from the simulation. So for A is a seismic interpreted line, and B is the cross-section of the first seismic line, where where the movement of faults, you can see the faults and also the flow of the syn wave, post wave, and also the passive margin are visible in the seismic line interpretation here. Also, this shows a line of conformity where the unconformity line represent the boundary between the pre-collisional of the line according to the paper review. Next is the theoretical substance, shows the theoretical substance sediments volume eroded from the mountain and feeding the western foreland basin was corrected for the fuel discharge flowing to the east, which is currently 45%. You can see here, A organ group model is a steady state organ wide with 90 km and a southward propagation rate of BP equals to 30 minus 90 km, or in a range of 30 to 90 km. And B is a theoretical value eroded from the mountain. And C is the modern river discharge, where here in C is stated in the report, the river discharge flowing to the east, which currently is 45%. Next is three models. So for model A is simulated with a southward propagation with 90 kilometer and a fixed y. It basically is a 3D model of the previous data. So model previous result from the last slide. So model B is the length of origin was fixed and lateral propagation allowed. Model C is combined by a oblique collision and a southward propagation. Next, here is a calculated sediment volume in the foreland basin produced with the three standard collision modules. Um, and the preserved sediment thickness in the Taiwan foreland basin is between 70 to 125,000 per kilometer cube. Now for conclusion and recommendation. So for conclusion, um, the sedimentary system of the Taiwan foreland basin is governed by an oblique collision between a Luzon volcanic arc and the Asian Pacific margin. So you can conclude that the different geometrical model of the organ growth and its influence on the basin architecture were tested by means of the stratigraphic modeling approach just now, all the results, and nearly 50% of the portion of the sediment are mostly eroded from the origin is not preserved in the stratigraphic record of the immediate adjacent foreland basin. So, um, uh, as recommended in the paper, it is most likely transported to the northward into the Okinawa Turf and the southward into the South China Sea, where large submarine channel lobe system developed. So this interpretation is consistent with the increasing amount of uh, submarine uh, incision since the late Pleistocene observed in the southwest Taiwan. Reference. Uh, that's all from me. Uh, Thank you for hearing my presentation.